Right, welcome everybody, and thank you very much for all joining us for today's webinar from the IMechE. Today's one is 3 steps to mastering maintenance and reliability. So, as way of introduction, my name's Dan Sanders and I'm the moderator for today's session. Just a little brief background, I work for the L&D team at the IMechE, and as well as providing these type of webinars, our team actually produce a number of other training programs and courses for individuals and organizations, but delivered on site, both in a kind of virtual or face-to-face setting. So throughout today's session, in the attendee chat box, I'll be keeping you updated with a number of web links for probably more relevant courses that are related to today's webinar. So please keep an eye out for those web links into the attendee chat box. Really just a couple of housekeeping points before we kick off. If anybody does experience any kind of technical difficulties, please do message us in the attendee chat box, and we have a team on hand that will be able to respond to you directly. This webinar today is going to be fairly interactive. We have a poll going on, so if you would like to get involved, please do. When the questions come out, just answer through the poll system. And we'll also be having some time at the end of the webinar for some Q&A. So if you would like to get involved, obviously we can hold some of the questions throughout. So please, you can ask the questions at the end, or if you want to put them into the chat box during the webinar, please do. Anyway, without further ado, I'd like to bring on board one of our most seasoned presenters now, Matthew Lazash, welcoming him to today's webinar. So over to you, Matthew.
Thanks very much, Dan, and hello and welcome everybody. Thank you for joining. My name's Matthew Laskay, and today we're going to be talking about maintenance, or most importantly, the importance of maintenance. Perhaps you're struggling in some of these areas. We all know that maintenance is a key to business success, but maybe you're struggling with the business case. How do you justify the spend or the amount of work that you need to do? Maybe you just need to understand what your actual productivity and reliability is. Or maybe you just want to know how to start, because that can often be the hardest part. So today I'm going to give you my 3 key or core steps that are going to help you on your journey. So let's get the slides going. So for your maintenance plan, to get your maintenance strategy going, there's a number of key things you need to know. Maybe you want to improve your safety. Maybe you just want to reduce costs, your maintenance costs, your production costs. Getting rid of all of your spare parts saves you money as well. If you want to become a more process stable business, more predictable, so you know what's coming, when it's coming, you want to make your assets last longer. Maybe you want to focus on the personnel, less overtime, less stress, increasing the ownership, the feel of ownership and the involvement that the employees have. Or the ultimate aim of any business is obviously to increase profits. So there's 2 main things you need to know to be able to do this. First, you need to understand what are the fundamentals of maintenance? What are the choices that you've got? And what do you need to do to be able to optimize a plan? And the second part, which I've already mentioned, is how do you build your plan? Where do you start? Picture your own workplace for a minute. Have a think about something breaks down. Production calls up maintenance. Quick, get out and fix it. So they rush over. Production's putting them under pressure to get it fixed quickly. So they're stressed. They get it working as much as they can. Perhaps the production person's gone off for their break or gone off for a cigarette or something during that time, and the maintenance person's left there all alone trying to get this done. So there's pressure from production to get up and running. They're stressed. They're overworked because of the numbers of breakdowns. So they're doing the band-aid fixes, the temporary fixes. Standards are dropping because they're doing so much work under a rush. because all of their efforts are going to breakdowns, they're missing the planned maintenance. You miss the planned maintenance, you get more backlog, you get more breakdowns. And this cycle keeps on going on and on. More stress, more breakdowns. Some people thrive in the firefighting mode, but ultimately it's not sustainable. So how do you get out of this cycle? How do we get out of this reactive troubleshooting style of business into something where it's a little bit more planned? I'll answer that one in a minute. But first, I want to talk about some of my experience. A supervisor might get promoted into a manager position. They want to do a good job. They want to impress. So what do? They try to cut costs. If I save money, I'm going to be shown to be doing a good job. The easiest place to cut money is maintenance, because maintenance doesn't make money, it costs us money. Production makes us money, so we can't cut there. So they cut maintenance spending. After 2 years, they've done an awesome job. They've saved money. Things aren't failing too badly. Production's still up and running. They get promoted. Who gets put into their position? Probably the supervisor that was below them. Now what happens? Things start to fail. Things start to get worse and worse. Things start to break down. Costs are increasing. Stresses are raising. We're back into this reactive cycle. But how do you catch up again? How do you get out of this cycle when the last manager's just done such an awesome job saving money? You're going to go in there on your first week and ask for more money? Good luck with that. So how do you catch up? How do you get out of the reactive cycle? The answer is the same, through a good maintenance plan and a good maintenance strategy. So what you need to do is improve your maintenance plan. If you look at what the purpose, other than all of those things I've just mentioned, the goal of maintenance is to keep your equipment working in good order, as cheap as possible. And for me, there's two main areas that this involves. There's the technical actions, the things that we physically need to do, the spanner, or what they call the wrench time, getting out there and fixing things, putting the plans together. And then there's the administrative actions, all of the work in the background that has to go on to make sure our records are up to date, our planner knows what to do, scheduling is right, all of that administrative tasks. They then group together to do the maintenance. And for me, the purpose of maintenance is to get that item in the existing condition or back to the existing condition in which it can perform its required function. So we need it to perform that objective, the reason why we bought it in the first place. If you look at maybe a better definition, it's a person named John Mowbray, who I'll talk a bit about later on. And his definition is that it's ensuring physical assets continue to do what their users want them to do. So we need to define what that equipment needs to do. Maintenance's purpose is easy. Keep it doing what we want it to do. I saw a quote a while ago, and it was when the oil downturn sort of came out. I live in Aberdeen, and I've been up here for a number of years now. And like in most industries, the oil industry has its ups and downs. And the last big down was about 2015. And there was a good quote here, and Robert says, it's a major hazard sector, the oil and gas industry. And because of the downturn, things were getting put off, things were getting delayed. Safety critical maintenance was getting delayed. But is that okay? On the surface, it sounds like it's not. But when you really look into it and break it down, we can make decisions on maintenance as long as we follow some core principles. Having a good management system, assess the risk, and make sure you involve the right people. I've got here technical, or he's mentioned technical and engineering authorities, but I will also include in that operations and maintenance personnel and manufacturers. As long as we involve these people, we have good systems and we assess the risk, there's nothing wrong with deferring maintenance or changing our plan in the first place. It's been really tough for most businesses in the last 12 months to get maintenance done, particularly offshore, because they can't travel. So they've had to do this same thing 6 years later, and it's going to keep on coming through. Maintenance is a bit of a cycle, or operations is a cycle, but it's changed over the last century or so. If you think back to the early 1900s, what was equipment like back then? It was slow moving, it was over-engineered, didn't have too many problems, there wasn't a lot of pressure. So when things broke, no problem, let's just go out and fix it. But then what changed? The Second World War came along, and all of a sudden the pressures on industry ramped up. Companies like Ford went from making vehicles to military equipment. A lot of other businesses had the same changes, and with that came pressure. We had to get equipment out fast and to a good quality. So we couldn't have equipment break down and unexpectedly. So we changed philosophy then from, if it ain't broke, don't fix it, to let's prevent it from breaking down in the first place. Every year, let's overhaul that bit of equipment to make sure that it's going to last another year. Let's remove it before it breaks down and replace it with a new piece. Let's do some basic overhaul work. That was all right until about the 60s, and then pressures changed even more. The introduction of things like quality management, safety becoming more important, environmental importance has increased in the years. So rather than trying to prevent something happening, let's monitor the condition and fix it based on condition to manage that risk a bit better. As time evolved, so did our thinking. What can we do that's even better than monitoring condition? We can be proactive. Let's proactively try to get rid of any potential faults that we could have rather than monitoring a fault that we do have. We're going to base our decisions on risk, and it's exactly the same as what Robert said in that quote there. Manage our risk, involve the right people, try to prevent failures if we can, and manage the condition of the equipment. So the thinking has changed. It doesn't mean that we're not using these past techniques. It's just we've got a better toolkit and a lot better options now to manage the pressures of time, resources, cost, quality, safety. I put together here a little bit of what I call a hierarchy of maintenance. And again, it doesn't mean that one's better than another because it's going to depend on the situation. But early on in the century there, we had the reactive maintenance as the predominant one. We then got preventive maintenance, or what we call planned maintenance. We're going to put a plan together. Predictive maintenance is one step better because we're going to try to predict when the failure has started. There's a concept called total productive maintenance, which was introduced by Toyota mainly, and I'll talk about that a little bit later. And also reliability-centered maintenance. This had a huge impact on the way we think, which led to this risk-based maintenance thinking. So a very brief overview for those of you who may not be as familiar with some of these concepts that I've talked about. And I saw this a while ago from somebody. I thought it was a great idea, that having some images there of sort of the rough era when these were one of the main dominant things. So I've got a car there. Being a mechanical engineer, everybody thinks that I'm a car mechanic. So I like to talk about cars a lot and have references back to cars. So here's a sort of a car from the era when reactive maintenance was popular. If we get a fault, isolate the equipment and fix it. Pretty simple. If it's not broken, don't fix it. The failure is obvious. It's what we call evident. Our task as the maintenance team is to bring it back to the condition that we intended it to function in the first place. Some other people call it corrective maintenance or breakdown maintenance or run to failure. They're sort of very similar, slight differences, but more or less what we call reactive. We're going to react to that failure. Okay, so then the war came along, and we're going to try to prevent a failure coming in the first place. Reduce the number of breakdowns. We're going to choose intervals for the maintenance: daily, monthly, 6 monthly, yearly are the sort of the typical times. We're going to do some checks, operation checks, visual checks, basic lubrication, filtering, servicing, those kinds of things. Again, your MOT sort of servicing for your car is a great example of preventive maintenance tests. Overhaul it if we think we need to make sure that it's going to run for another period, restore it, throw it out and replace it altogether. All of these are what we're calling preventive maintenance. As an engineer, we obviously love to see graphs. We love to see information. So here's a graph which perfectly fills what we call this preventive maintenance understanding. At the start of its life, a piece of equipment has a small amount of chance of failure. Okay, so nothing's going to be zero probability of failure. As the time increases, it's roughly what we call random chance of failure. It doesn't increase or decrease, it's roughly the same until we get to this what we call a wear out zone. It then gets to the sort of the end of its life and it starts to wear out, and the chance of failure increases much faster. So the ideal time for us to perform our preventive maintenance or our replacements or overhauls or discards or whatever we're going to do is when we're getting to the point where our probability is starting to increase above our comfort zone. So roughly this dotted line, wherever that dotted line is for your piece of equipment. Hopefully you're starting to see now the problem with this theory of preventive maintenance. There's a few assumptions we're going to need to make in order for us to make our decision on that, where that dotted line is. Is that 6 months, 12 months, 2 days? We're going to assume that that piece of equipment follows this profile, that it's pretty reliable at the start of its life, it runs through this lifetime, and then it gets to this magical dotted line at the end. The second part is that we actually have the information in the first place. We've got our failure statistics or our data to make an informed decision. What are the chances of your business having pretty good failure data, failure statistics? And then the third one is that all equipment is average. If I have 2 pumps sitting side by side and I run one for 1 week and one for the other week and then one back again for the other week, do you think they're going to both fail on the same day or the same week? No, because most of equipment is not average. One exact same pump running under the same conditions may run at a completely different time. Now throw in the operating context. What's the environment that we're running in? Now there's a huge amount of extra variables. So if it's unlikely that a lot of equipment doesn't follow the profile, that our information we've got is not reliable or accurate, or we don't even have it, and equipment's not average, why is the majority of our plans for our business based on planned maintenance? So to help with that concept, I'm going to go back to the 60s and tell you a story. So in the 60s, the airline industry wasn't as reliable as they would have hoped to be. They were having too many failures, and if you have a failure in an airplane, it's pretty bad. So what do you do when you have a failure in your plant, in your organization? What's the first thing that you would do if you had a failure? In most cases, you're going to do more maintenance, aren't you? Right, this keeps failing. Let's maintain it more. Let's overhaul it more. Let's make sure that the bits in it are new and we've done checks to make sure it works. So that's what they did. They did more maintenance. They added redundancy. They over-designed things to make sure they weren't going to fail. What they actually found was that the reliability did not improve. And in a lot of cases, it got worse. What? How is that possible? How can you do more maintenance, but not only does it not get better reliability, but we get worse? And that's exactly what they thought. So they brought 2 people in to do an investigation, to do a study. Their names were Nolan and Heap. And in the 70s, they did a report based on what they'd found. They actually found that instead of being this one failure profile, like I just showed you the classical failure profile, the A in this graph here, Rather than there just being this one typical profile, they actually found 6. The first one I just talked about, the classical failure profile, more or less random throughout its life, and then gets to the wear out zone at the end where it increases in the chance of failure. The second one, which many of you may have seen before, higher probability of failure at the start of its life, and then after that it more or less follows that classical profile. C, pretty good at the start, and then just gets worse and worse and worse probability as it gets older. D, pretty good at the start, and then jumps up quite quickly to a higher chance, but still random. E, just low random throughout its life. So almost think of a light bulb. You don't know whether that first time you're going to turn the light bulb on, it's going to work. Maybe it will. Maybe 1,000 hours later, you still don't know whether it's going to work or not work. So it's pretty hard to tell what the lifetime of some of these equipment is. And then F, high probability at the start of its life and then less after that. So what I'd like you to do is we're going to put up a poll just now, and I'd like you to pick which one of those 6 do you think that they found was the most common failure profile for the airlines that they did the studies on. Is it A, the classical, B, C, D, E, or F?
So for those of you who can see, we have an event polls tab. If you'd like to click into that, you should be able to type in your result on either A, B, C, D, E, or F. So put it into the polls chat, polls tab, please. Okay. Whilst we're waiting, the results are being gathered at the moment. So if you wait a few more seconds.
Yep. So which one do you think they found at the time was the most common? Okay, 5 more seconds and we'll reveal the grand reveal.
There's obviously a lot of people have answered. The results are still coming in.
Okay, excellent.
Okay, maybe. We've got them. Okay, so the most common answer was B. Okay, with 53% of people went with that answer. Second was C with 13%, and then D, 8% of people went with that, and then the rest. You've got E was 9%, F was 10%.
Excellent. Well, I have to say that's probably what I would call a typical result for this kind of question. And I would say that most people answer B, possibly because they see that as a familiar profile. It's what we call the bathtub curve. But 53% of you have said B. What I can actually do is reveal the results, and they might surprise you. 4%, just 4%, followed the bathtub curve profile. And this is exactly the reason why they had the surprise of doing more maintenance in the 60s actually didn't help. And this is why they got Nolan and Heap to do the study, because they all believed exactly what you believed. That most equipment follows that profile B. And that's why we do preventive planned maintenance. So only 11%, if you add all of those 3 curves up together, 11% follow what we call age-related profiles. So they get to this wear out at the end. Only 11%. And you might say, oh, well, that's fine because that's the airline industry. That doesn't count for my business. Well, there's been a lot of studies that have been done since this time, and the results are pretty similar. 17% for the Navy. So the Navy one was done on a submarine. So the submarine has a much higher risk than most manufacturing plants. So the numbers are slightly different for that one. But manufacturing is exactly the same as the airline. So what's the answer? The answer was F. So for the 10% of you that answered F, gold star to stick on your fridge. 68%, and it's what we call infant mortality. Higher probability at the very start of its life. 89% follow what we call a random profile. 11% age and wear related, 89% in this random. You notice there that there's no kick up at the end. And again, what about other industries? Again, the submarines, slightly different, but still much higher random than wear. What does this tell us though? What does that really mean for our business? There were two important discoveries that they found from these graphs and from this investigation. The first one, that scheduled overhaul or planned maintenance has little effect on the reliability of a complex item unless it has a dominant failure mode. So we're talking about complex items here. We're not talking about a single cantilevered beam which cycles back and forward, because we can predict pretty well when that's going to wear out. That dominant profile there would be a fatigue, crack over a certain time. So we're talking more complex systems here, maybe pumps, maybe hydraulics, maybe some of those sorts of areas. So scheduled overhaul has little effect. And there's a lot of items where no form of scheduled maintenance will help. Think about your business again, and I'm going to bet that most of your maintenance is planned maintenance, because we like to feel comfortable that we're going to do maintenance to prevent failures. But if 89% of equipment in this study actually had no what we call end of life, why are we scheduling an overhaul at the end of its life? The key things here for me is don't do maintenance unless you have a good reason for it. Because if you do maintenance, if you tinker with it, we're going to start that graph again, and we're going to go up to a higher chance of infant mortality. How do we get around it? Monitor the conditions. Monitoring defects, preventing defects before they happen, or proactively. If you look at what we call asset management standards, ISO 55000 series, or 55001 is the actual standard for asset management. It looks at the life cycle of a product or life cycle of an asset, how we design it, how we buy it, store it, install it, start it up, shut it down, operate and maintain it. We have to look at the whole management life cycle. Predictive maintenance is one way to do it, one way to improve it. Okay, so if it's going to be a random failure, what's the point of changing it over when we don't know when to change it? We can't let it fail if the consequences is too high. So let's try to predict when the failure is going to occur. Visual inspection, oil change, oil checks, temperature checks, condition monitoring, non-destructive monitoring and testing. But don't forget operators. The operators are there every day. They know how the equipment runs, sounds, behaves. Get them to look at it, listen to it, report any defects. It's a really good way of monitoring the condition to detect a lot of the defects that we could possibly have. If we want to be more proactive, remember I said proactive maintenance is at the top of my tree there. We start to do things like root cause analysis. Eliminate the defect before it even happens. If we do have a defect, figure out why, prevent it happening in the first place, or even better, let's do Fmea, finite method, failure mode and effects analysis. Again, remember, a lot of traditional maintenance achieves nothing because only 11% of the time in that example, we had wear related or age related. Sometimes we actually make it worse. Design it, procure, install it, operate it as best practice. Follow the asset management standards, follow the best practice to get to that world-class standard. Total productive maintenance, I mentioned this with my hierarchy earlier as well. Started mainly in Toyota in the 70s as well, when some of these thinkings were coming through. Total quality management was another one, is to have no waste, that lean manufacturing philosophy. And it's based on 8 pillars surrounding the 5S. So the 5S, which a lot of you may have heard about, sort, shine, all of those S words. And it's all about getting the workforce involved in making decisions, the ownership of the employee, focusing on training, management principles, understanding maintenance principles. The thing that came out of the airline industry study is what we call reliability-centered maintenance. So Nolan and Heap's study changed over into what we now know it as RCM. And there's a really good book that they put together called RCM2. Remember that quote I gave you at the start, the definition of maintenance by John Mowbray? John Mowbray was the author of that RCM2 book. It's a process, a system that uses a flowchart and decision diagrams to help us make decisions. Rather than going on gut feel as much, we're answering yes and no questions to then choose the best technique, the best strategy. Back to his definition there, the aim is to make sure the equipment continues to do what we intended it to do. So this process just helps us to do that based on the operating context or the operating condition, outside, inside, temperature, use, product, all of those things affect how our asset is running. So the RCM process asks us 7 questions. What is the function of the asset? What's it meant to do? How can it stop doing that function? What causes that failure? What happens when that failure happens? So what's the consequences of that failure? What can we do to either prevent the failure from happening in the first place, preventive maintenance, or predict the failure, planned maintenance, condition monitoring, all of these things? What can we do to try to get to that point? If we can't do that, what else can we do instead? Maybe it's redesign it. Maybe it's change it altogether. So as a process map, as a plan, as sort of how I see this fitting together, collect your information. Assess the risk, which is a combination of consequence times probability. Rank the risk, highest to lowest, focused on the biggest problems. Build a plan, and you might want to use RCM to help you decide how you build that plan. If you're looking at the plan, do, check, act cycle of continuous improvement, we always want to evaluate how we're going. We may need to go back and reassess our risk again and continuously improve it. We can now build risk-based techniques into this program. So risk-based inspection, API 580 is the standard for that. Add that to RCM, and we've got what we call risk-based maintenance. We're going to use the philosophies from RCM, using what we know about risk. RBI is mainly about thickness measurements for piping and pressure vessels, and we're going to do our decisions on that. Right, that was a whole lot of information, right? So we've got reactive maintenance, planned maintenance, predictive maintenance, condition-based monitoring, reliability-centered maintenance, and proactive. What do we do? How do we know that it's even going to work? So I want to go through an example of when I've used this in the past. I used to work in an edible oil refinery. So back before I moved to Aberdeen, I used to live in Melbourne. I'm from Melbourne, Australia originally, in case you're trying to pick the accent. And I worked in an oil production plant, edible oils and margarines and fats. And we introduced a new program where we're going to revise every one of the production lines to improve the productivity and reliability. And I say this is probably the exact reason why you wanted to join this webinar in the first place. So we reviewed all of the equipment in the packing plant. How did I do this? Collect all of the plant maintenance you've got. Get it all together out of all of the areas. You're going to have some formal on your planned maintenance charts. You're going to have things on the walls. You're going to have maintenance in their heads. Get it all down on paper. Sometimes you're going to have it all grouped together. So break it up into individual tasks. Get all of your failure history together, because if you want to be proactive, we want to look at the causes of the failure as well. CMMS, Computerized Maintenance Management System. Get it out of that. Get it out of experience from your people. The most important part is to have the right people. The maintenance engineer or the reliability engineer on their own cannot do this by themselves and have a good strategy. You must include the maintenance technicians, the operators, the original equipment manufacturers if you can, supervisors, as many people as you can. So we sat down in a room, one production line, we sat down for 1 full week in a room. If you've ever tried to get maintenance and operators in a room doing paperwork for a week, you'll know how hard that might sound. Review every task. Come up with a new strategy for each individual piece of equipment based on the consequence of the failure and put it all together. So what were the results? What did we actually find? Was that 1 week of a team in a room plus many months of my work before that actually worth it? So let's look at the mechanical part of this first for one production line. We deleted 78% of existing tasks. Why did we delete 78%? Because they achieved nothing, or they made the problem worse. We introduced 11% new tasks, and the reason we could have less is because we didn't actually need to maintain a lot of it. We could have them run to failure because the consequence didn't warrant us doing maintenance in the first place, as long as we've got a plan. So we reduced the mechanical maintenance hours almost by half on that one production line. What about electrical? Okay, I know we're all mechanical engineers here, but we do have to think about electrical sometimes as well. The hours for electrical actually increased slightly. Only slightly, even though we added 83% new tasks and only deleted 15%. The reason was because they were doing quite a bit of lengthy electrical maintenance tasks, but they weren't effective. So we added a huge amount of tasks, but very short and easy tasks to do, rather than the lengthy tasks which weren't that productive. So overall, we deleted 39% of the tasks in the whole production plant. We only introduced 27% new, and then we changed a few around here and there. But the key thing is we reduced the hours by 1/3. Not only did we reduce the work, but I would say we made the equipment far more reliable. Double win. The key findings were we moved things from a calendar-based to meter, because not every production line ran 24 hours. Move as many as we can to condition monitoring because we had random failures. We did an oil analysis on some of the big gearboxes. Equipment was serviced far too often, and a lot of people were doing the same tasks. Not many electrical ones in place, so we improved that as well. Okay, so that's for a production line. What about a refinery? So when I moved into a new role in an aluminium refinery, Alumina, they had 5 production lines, and their plan was to take one flow line out every 14 weeks for 8 days. Overhaul it. When I got there, the idea from somebody was, right, let's try to change that so that it's more reliable, exactly the same thinking as the airlines. We're going to do more overhauls. We're going to go for a small one in 7 weeks and a big one in 7 weeks. We're going to double the frequency of overhauls we do. Waste of time. It's unlikely that was going to happen or have an effect. So what I did is the same process. I got everything together, I got a team in place, and we reviewed it based on the information we had. The new proposal was actually to go from 14 to 18, to go from 8 to 6. And I did all of this on Excel. I didn't have fancy software, didn't have fancy analysis. It was all just done based on understanding the techniques. Saved 250,000 Australian dollars a year by just doing it in Excel. So I'm pretty sure that covered all of that work that we put into all of that time. So what's next? Once we understand the fundamentals of maintenance, what else can we do? The future is in the technology, the Internet of Things. If you've got an app for running, we can use similar things for monitoring the condition of our equipment, remote monitoring without people going to it, the Internet of Things. Artificial intelligence and digital twin can help us predict what is going to happen in the future. Collect as much information in as you can, but only if you're going to use it. Try to then use that information to give us a better understanding. Blockchain technology, it's more than just Bitcoin. It's having an open transaction record of what we're doing. Augmented reality, virtual reality. We can use goggles and things to help us work and track what we're doing. Don't forget cybersecurity. We need to make sure our equipment is secure and our information is secure. So now what? Now what do you do after all of that? So if you want to save money for your business, because that's ultimately our aim, we all want to improve safety. We want our plant more predictable so we can plan better. We don't want to be stressed. We want to be happier. If you want all of this to become our manager now, rather than the person who is following somebody who has spent 2 years looking great but really messing up our plant, I'm hoping you know now what to do. My 3 tips on how to achieve this is set up the support first. The leaders have to provide the vision and the goals. The operators provide your basic care and your first line monitoring. Don't tell operations this. This is a secret between us, but maintenance and engineering are there to support operations. Okay, that is our task, to support production, because production is where we make the money. Engineering and maintenance support that through some more advanced detection methods and problem-solving methods. Number 2, do the right things. You need to make sure that if you're going to put a task in place, it is the right task to manage that problem. You can use RCM and TPM and risk-based methods, but ultimately you need to understand the fundamentals first. And number 3 is to embrace and utilize new technology, but not before you've got your basics right first. Do not go out and buy all of this fancy technology when you haven't even got the right techniques in place in the first place, because we're going to spend a lot of money to achieve nothing. So June is maintenance month. We are having a maintenance month with the institution to help you on your journey. Start of June, we've got what we call world-class maintenance. World-class maintenance is the fundamentals of how to put a maintenance plan together, understanding all of those concepts that I've just covered there, and developing a plan so that at the end of that, you go away with the steps and the tools to make up an optimized maintenance plan. Once you've got the fundamentals in place, or you maybe already have that in the first place, then it's time to get more advanced through some reliability-centered and risk-based systems. So looking at Fmea, looking at consequence management, risk management. If you're working in production lines, you can look at what they call total productive maintenance, that one I talked about, the 8 pillars. Or maybe you just want to manage your entire life cycle of your asset from acquire to maintain, operate, and dispose. Then asset management is maybe the one for you. And to celebrate having this webinar with all of you awesome people from all over the world, we've put together some bundles. So if you join up 2 courses, you can actually get a discount for that. So the world-class maintenance RCM or the asset management and world-class, because I think they're the ones that go together as pairs better. So what I would love to do, I think in the links there, I can't see the links yet, but I'm thinking the links there's some links to the website if you want more information of those. Or please feel free to connect with me on LinkedIn and Facebook. My name is pretty easy to look up when you know how to spell it, Laskaj. There's not many of us around. So feel free to link in and ask questions. And what I'd love to do now is to throw back to Dan and to see if there's any questions you've got. So I will stop sharing and go back. And Dan, hit me with the questions.
Right, lovely. Okay, yeah, thank you very much, Matthew. That was really good. That was really interesting. And as you said, you put up some details of some of the courses there. So if anybody, if there's been an appetite for learning more about these particular subject matters, then obviously please do head over to the web link that is into the chat box to get access to some of the dates and more in detail about those courses specifically. We have got some time for some Q&A, which is great. But before we kick that off, we're going to be putting out a SurveyMonkey link into the chat box. So for those of you that would like to just give us a little bit of feedback on today's session, that would be much appreciated. So whilst we're doing the Q&A, please do feel free to fill in that information. So yeah, so Matthew, some questions have been coming in throughout, which is really good to see.
Yep.
So I'll kick off with one here. This came from Jim Adams. He says, one industry I worked in went big on RCM and then couldn't get the spares because the market for them had dropped because of the RCM. What's your opinion, please?
So the first part of that was we were trying to...
They went big on RCM and then couldn't get the spares because the market for them had dropped.
Okay, so when we're doing RCM, we want to make sure that we only do RCM on the things that are really critical, because RCM takes a massive amount of time and money and effort. And if you all of a sudden go, here's our plant, let's make it awesome and do RCM, you'll never get to that end goal. So part of the RCM process helps us decide what's the consequence of that failure and how do we manage that consequence. So through that study, you need to iterate. So basically, here's our best strategy. Let's see how it worked and let's revise it. So if you find at that time when you've done your first initial assessment that here's our strategy, here's the spares we need, then you go back to find that the spare parts aren't available, you need to reassess that choice that you made in the first place. Even though that technique might be the best one for that piece of equipment, if you can't get the spare part, there's no point doing that as your technique. So you have to take into account that the spares is part of that choice. So if it was run to failure based on having spare parts available, you can no longer let it run to failure. If the other options aren't okay, you're going to need to redesign it. So you have to take the spare parts as part of the solution rather than as a choice later on.
Okay, fantastic. Thank you, Matthew. And just to let you know, the feedback coming into the chat box is absolutely fantastic. Everybody has been saying it was a very interesting presentation, very informative, very well presented, all at the right level. So
okay,
great at the beginning. That's really good to see. Another question here from Igor Martik. He said, so we should aim to buy already used equipment with proven history rather than the brand new one, as in a question there. Sort of thing.
Okay, well, that's actually a great question. That's not one that people actually pick up on. So well spotted for thinking like that. So when you're using equipment, you have to try your best to understand how it's going to behave, but ultimately you're looking at what's the consequence of that failure. If you want to be more, I suppose, comfortable that you know that curve, then you buy equipment that has got good analysis already performed. If you're buying second-hand equipment, I don't know if that's the part of the question you were talking about. If it's second-hand equipment, you need to be careful because you don't quite know the condition of it. But if it's equipment that's been around for a lot longer, you're going to have much more confidence or much better information to help you predict what your curve's going to look like. So if you think about a car that's been out for 6 years, it's a good chance they've ironed out a lot of the kinks in production problems. Whereas if you buy the first car out, there's a good chance that there'll be more problems. So I'm not saying don't buy the first thing that comes out, because we often like that, but you've got to have a plan in place. What happens if it fails, if you don't know?
Brilliant. Okay, thank you, Matthew. And you've already changed someone's opinion on maintenance.
Have I?
You're really making an impact here, Matthew, which is great.
Oh, good.
So Jonathan Holmes here has asked the question, what is your view of the use of Fmea for defining a maintenance strategy?
So Fmea is failure modes and effects analysis. So consequence analysis, what's the effect? So Fmea looks at what could happen, whereas root cause analysis looks at what has happened to eliminate that. So it depends on, firstly, if the failure has happened, I would suggest doing root cause analysis to find out what's the root cause and stop that happening again. If it's something you want to prevent happening in the first place, then you do an Fmea, because what we're doing, it's a similar process to RCM, where we're going to look at what's the function, what's the potential failure, what's the consequence of the failure, and are we happy with that consequence based on risk? If we're not happy, do something about it. So Fmea is a really good thing to look at to say, are we comfortable with where the risk sits now? And if we're not comfortable, what can we do to reduce it? So one's kind of looking one way, one's looking the other way.
Okay, brilliant. The questions keep on coming, Matthew. Right, okay. So this one's from John Baker. Yeah, I've found this very incredibly useful, today's session, which is good. But have any reliability trends been noticed between organisations who outsource maintenance to those who have in-house maintenance engineers?
Yeah, there's been lots of studies on that. I can't quote any figures off the top of my head, but what I can tell you from what I've seen and what my experience is, that you've got to be careful outsourcing maintenance. So first off, remember I spoke about the operator is the perfect frontline person to detect a problem because they're there. Think about you as a car driver. You get in your car, you're going to know if something's wrong. You take it to a mechanic and they'll say, is that not what it's always meant to sound like? If you have a maintenance team who are always there working with the equipment, they know the equipment better. They know what's been wrong in the past. If you outsource it, you're almost bringing in somebody who potentially has no background information, depending on if it's their equipment or not. If it's a manufacturer's piece of equipment, they're going to know it better than your in-house potentially. So that might be a good reason. The second one is if you outsource, think about how long it's going to take them to get to it. If they're remote, they might have travel time, or if they're not there. So for me, it's a cost decision, I think, is what most people do it based on. But I like to have people who know the equipment because, again, that ownership. The maintenance people, they want to do more proactive because they don't want to have to come back next week and fix it again.
Okay. Yeah, again, I think you're making an impact. Some people are saying here already that they're guilty of using the preventative maintenance. So you're already making people aware of what they're actually doing here. So
it's a comfort thing for a lot of things.
One here, a straightforward question from Igor, from David Vass. Hi, Matt. Should you consider the impact of the failure? For example, if you live in a country with a wet/dry season and the windscreen wipers fail at the beginning of the dry season, should you care until the wet season?
So again, it's down to what happens when it fails. So if your windscreen wipers fail in the summertime, does that matter? Would you even know? If it fails in the wintertime, how long does it take you to change it? Do you have spare parts? can you still drive for a amount of time while they fail? So you look at that part of it rather than how do you stop it from failing in the first place? Because we all know that windscreen wipers, as an example, will fail at some point. Would you change it at the start of the summer season? In my opinion, probably not, because you're not going to use it in the summer and it's going to deteriorate in the sun. So I'd probably do a check or something at the start of the winter.
Okay. Another one here from Jack Andrews. He says, we use ILS tools, including DFMECA and MFMECA and HAZOP studies, ensuring currency of these docs take up significant time or resource. Does your approach, he looks like you know what the cut's coming, does your approach support the business case to continue to apply resource to these tools?
Okay, so it's your business case based on your equipment and your goal. So I said that RCM takes up a massive amount of resources and time, and you're not going to do the full process on something where, again, think of a light bulb in a room. You're not going to do too much on that, because if that fails, you go to your cupboard and get a spare one. Same with FMEA. You might want to do an FMEA on everything if you've got the time to do it, but you're only going to act on the things that are the highest risk. You're going to put it into an order and you're going to risk rate it, and then possibly you're going to only do it on the higher risk ones and then work your way down that chart. So it depends on risk to me. I would suggest, even if you wanted to do it on everything, break up your business into chunks of work. Because if you just go and say, right, let's first do an FMEA on everything, and then you spend a year doing that. Right now, let's do RCM on everything, and you'll never get to an end. Take a small bit first and then work through it that way.
Okay, fantastic. Thank you. A couple of questions have just come through. Actually, they're very similar. Both one from Cassius Mentemba and Stuart Tan. They're both virtually the same what they're saying. So how do you change the culture from a PM mentality to a CBM mentality? As you said, it's a comfort thing. Where do you start? And Stuart said, how do you convince the senior leadership to sign off changing from PM to CBM when they've been practicing?
Great call. The first thing I would say is don't focus on going to condition monitoring, because that's not always the answer. In the examples I gave you, most cases it was a better option than the others. I'm not saying that reactive isn't the best plan, planned isn't the best plan. It's just more often, if you have random failure profiles, condition monitoring is more effective than the others. So don't focus on trying to convince people that this is the best. That's what the team would determine. But to get to that point, you have to have the leadership and management on board to say, we want to make a choice. We want to make an improvement first. Once they've made the commitment that's saying we want to make an improvement, the second step is educating people on the fundamentals of those choices. So like I mentioned, that world-class maintenance course, understand what is actually involved in reactive, planned, and preventive and predictive. Once you understand the basis of the decisions, then it's easy, because they'll say, now I get what you're trying to achieve. Go and get your team together and do it. So I would say understand the basics first, do a very shortened version to them to say, these are the reasons why we're doing it, and then move from that.
Okay, maybe we've got one time for one more question. Will we use a lot of soak and hanger testing? Does that ring a bell? To avoid the infant mortality? Is this widespread outside of the rail industry?
I'm going to say that I'm not in the rail industry and I don't know the terminology. So
that's why I did feel that might be
maybe that would answer the question if that's it. So sorry, I'm not sure.
Okay. Right then, one final question. Type of service equipment is put in type of service and equipment is put in an important consideration in designing a maintenance strategy. How will one design the right strategy based on different surface?
Based on different service. So if you look at the asset management cycle, so again, what ISO 55001 talks about acquiring, operating, maintaining, and dispose and decommission. For me, a lot of people will draw a curve which shows the probability of failure for an equipment. I like to have, I haven't shown it in this webinar, I've got it as part of the course. I like to have a phase before that, which I call design, because you need to design for reliability even before you start operating and maintaining. So if you have the team of designers understanding how easy is it to maintain and operate, they will design a better. Again, for instance, if I talk about cars, how hard is it to maintain a Japanese car, an American car, or a European car? And I can tell you there's one of those three which are much easier to maintain, and there's one of those three which is much harder to maintain because of the complexity and the access and simplicity of the designs and things. So it needs to come in the design phase ideally, but most places will buy something that's already designed, so you're kind of stuck with what you've got. So then understand the fundamentals.
Fantastic. Okay, look, there's people in the chat box talking about the hangar testing now. So his questions are being answered by the attendant, which is nice.
We've got experts in the rail that
we certainly have. So, all right. Well, I think you know, I'd like to say thank you very much, Matthew, for today. That's been fantastic. The feedback has been tremendous watching it come through. So, thank you very much for joining us on today's webinar. And to everyone today who's joined, you know, hopefully you managed to fill in the SurveyMonkey details of the link and provide some feedback. That's always helpful to us for future webinars. And of course, you know, we've uploaded the details regarding some of the upcoming maintenance-based courses that we're coming up in June, July time. So if this has whet your appetite, please, you know, go online, have a look and sign up to the future ones coming up.
Don't forget to contact us if you've got any questions on that as well. We're happy to help.
Lovely. Okay. Thank you very much, everyone. Thank you.
Thanks, everyone. Bye.